Great to see you here. My name is Luc de Ceuster. Welcome to my YouTube channel. This is another video offered to you by us. And when you're here for the first time, do not forget to subscribe to the channel. Click on the subscribe button, click on the bell, and YouTube will inform you every time we have a new video for you. We've been talking about finance in previous videos. We've been identifying different parameters. And it's very important to understand how these parameters work because we want to use them to evaluate the efficiency of investments. We looked at the net present value, we looked at the profitability index, we had payback time, we had return on investment, but there are other parameters that are also very interesting and that we should understand and evaluate when we are looking at investments. In this presentation, I will talk about a new parameter, which is in fact the internal rate of return. And the internal rate of return is basically the yield of the investment. When we look at our investment, we have the discounted cash flows, we have the initial investment, and we can use them to calculate the net present value, which is very important to see that our project or our investment creates a profit. But we also want to know what is the yield? What is the yield of our investment? Just consider when you are putting money in the bank, you get a certain interest. It's a kind of a yield. And the internal rate of return is calculating that same thing for your investment. So we invest the money, we want to see what is the investment yield, and that's what we're going to do in this presentation. Now, we can define, in fact, the internal rate of return as the yield or interest rate for which the net present value equals 0. So basically, we have to find an interest rate. We're going to use the formula of the net present value and put their different interest rates until the net present value is equal to 0. Now, we've been doing that before. We've been using some investments. For example, we looked at the payback of a loan. Now, when we consider the investment and the money we pay, the money we lend to pay for the house, that mortgage, when we take the discounted future value, the payments over the years of the loan, we will see when we calculate the internal rate of return of this, let's say, of this case, you will see that the internal rate of return will be equal to the interest rate you have to pay to the bank. Now, there are more things to do about the IRR, the internal rate of return. And one of the questions we can ask, what has to be the value of the internal rate of return? Now, what happens? We lend money, we use money in a company, but that's not for free. So we also have to understand when we have a business, how much does money cost to us? So when we are using money to work in the company, what is the interest rate? What is the weighted average cost of the capital that we have to pay to use that money? And when we have an investment, the internal rate of return should at least be equal or higher than the weighted average cost of the capital, which is quite logic. If I would invest my money and my yield is lower than the internal rate of return, it means that although my project may be at a profit, because of the yield, I'm still losing money. So it's very important to identify that. Now, the internal rate of return should never be smaller than the WACC, because then you're not recovering the cost of the cash that you are using. And it's an important parameter to evaluate, and in combination with the net present value and the internal rate of return, we have a good view what the efficiency of our investment or our project is. The WACC is basically a lower boundary, and it's the minimum that we have to recover. Now, in some cases, when we have high-risk projects, higher risk means that we want to have a higher return. And the WACC being the minimum value, when we have highly or higher risk projects, we may want to impose an additional compensation for the risk. And then we talk about the required rate of return, or IRR, or sometimes also triple R. Now, the thing is, when we get the IRR and we compare it with the WACC, and when we are not within the conditions that are defined within the company, we may have to find other ways to invest our money or to select a different investment or project. Now, when we look at the palm tree dilemma, the internal rate of return, the palm tree dilemma is an idea I promoted and I explained to my students what the use of the IRR is. Let's just look at the IRR that we obtain. We have the net present value. So basically we can consider what to do with our project. The internal rate of return will determine if we are using, let's say, or recuperating the cost of the money. The net present value will tell us that our project has a profit or not. Now, the next thing what we have to do is that we have to see what are we going to do. We may have different options, and options may be to put the money in an alternative investment, for example, buying bonds or putting it on a bank account or buying stock instead of investing it in a project. And basically here is the idea of the palm tree dilemma. We find a worry-free way to invest our money, and instead of investing it in a project, which probably will give you a lot of headache, a lot of things that can go wrong, probably the results will not be as good as you imagined. So it may be better to put it in a safer investment and enjoy your free time under a palm tree. Now, be careful, because coconuts may be very dangerous. You have to be aware of the dangers related to the coconuts. Even your investment, your safe investment, can take different directions. For example, when we have some crisis situation like we are having at the moment with the Corona-19 or the COVID-19 situation. Now, when we are going to calculate, we want to find that value. Now, when we look at the formula of the net present value, we see that this is a formula in which you have to put the interest rate, but when we look at it, we cannot really find an expression which gives us the interest rate as a function of the initial investment and the cash flows. Basically, when we are looking at the formula for the IRR, we have to find or use the net present value formula, and the net present value formula in this case has to be equal to 0, and we have to change the interest rate by the IRR. So we have the summation of the discounted cash flows, where the discounting parameter is 1 plus the internal rate of return plus the initial investment. Now, the internal rate of return we don't know, and we have to find it. Now, typically when we want to find this expression, it's mathematically not possible to find it. So we have to find other ways to calculate the internal rate of return. Now, what we can do here is to use a mathematical method, which I also teach in courses like college algebra, which is what we call a trial and error. And what we are going to do, we are going to assume that the IRR has a certain value and put it in the NPV formula. And we try by adjusting the numbers to find an interest rate which brings the NPV close enough to zero. We will not be able to find exactly zero, and it's very dangerous in Excel to say we stop the calculation when the difference, for example, is equal to zero. It may never stop. You may end up in a loop. So you have to say we want to have a value which is smaller than, or the difference or the net present value is smaller than a certain amount. Typically, we want to find an IRR with 2 decimals. And once we find the approximations that the third decimal is stable, we consider that to be the exact internal rate of return. Now we come back to that later in some calculations. Now, luckily, we have, in fact, also Excel. But let's have a first look at the method of trial and error. And the method of trial and error is a mathematical method where we have a continuous function. And a continuous function has a very specific property. A continuous function is a function you draw without lifting the pen from the paper. And when we have on one side a negative value and the other side a positive value, the rule of the property of the continuous function is that we have to pass through zero somewhere. So when we have a value x1 and a value x2, and let's say the interest rate x1 and x2, and for example for x1 the interest rate gives us a negative NPV, for x2 a positive NPV, then we know that the zero is somewhere in between. So we find x0 by successive steps. And when we look at the graph, we have the percentage and the net present value. We have the evolution of the net present value as a function of the percentage, and we see that it goes from a negative value to a positive value. And there is some crossing on the percentage axis. We find for x1, we find that f of x1 is smaller than 0, so the net present value corresponding with the interest rate x1 is negative. We have a second one, x2, and for x2, the fx2 is larger than 0, or the net present value when we use the discount rate x2 is positive. Then we know that x0 is somewhere in between those two values. And this is the property that we are going to use if we want to do a manual calculation. Now, the manual calculation is not really difficult. It's just a consecutive number of calculation. If you would do it by hand, it would be quite hard to do it because of all the decimals. Luckily, we also have integrated formulas in spreadsheet programs. We have financial calculators, which will help us to work with the formulas in an easier way. And Excel has an integrated IRR formula. And the formula is in fact very simple. You put as parameter IRR, you select the values, all the values, starting from the initial investment till the last investment. And then in some cases you have to put there a guess. Now what's happening here? When we are working with the internal rate of return, we have in fact the investment, we have the cost, we have the cash flows, the periodic cash flows. All of these values are integrated in the term values in that formula. So we select everything. It's not like in the net present value where we took out the initial investment. The second thing what we do is that the calculations in Excel go up to 0.00001%. So the iterations that Excel is doing will stop when the difference is equal to this percentage. Now, there is some possibility that something doesn't work the way it should. And it means that in some cases the formula doesn't find a solution with the desired precision or the program precision. Why is that? Because Excel only gives 20 iterations. So when we have the iterations and we need more than 20 iterations, the formula will return an error. Now, in that case, we have to enter a guess. We have to say, well, we think that the internal rate of return will be approximately 11%, and then the program starts to calculate from that value. Otherwise, it just takes an interval and it can go wrong. So here you have to be careful. Anyway, the calculations of the internal rate of return, we can do it by programming it in Excel, but it's easier to use the integrated formula. Of course, we have to be careful that we have an idea where the internal rate of return will approximately be. So when we put that formula there and we see that it doesn't give a result, we can make quickly a table to see where the net present value goes from negative to positive. And then we put that value in the formula as a guess. The alternative way, and we will look at that in the next presentation, is a step-by-step calculation of the internal rate of return, which is very simple to do. You have to do the programming a little bit, and once you've finished it, you can do these calculations very easily, but you have to know a little bit more about Excel. This was the presentation about the internal rate of return, an important parameter because it gives us the yield of the investment. We can compare the yield with the cost of money for our company, and it's a very good parameter to say, well, is our investment good? Typically, we will not make a selection on the internal rate of return alone. When we are evaluating projects, we will not use the internal rate of return to select a project. It's typically a cutoff value. Every time when we see that an internal rate of return is less than the WACC or the required rate of return, we will reject, in fact, the investment or the project. On the other hand, when we have the internal rates of returns, when they are acceptable, we will use other parameters like the NPV. So this was the presentation about the internal rate of return. Do not forget to select the subscribe button if you didn't subscribe yet. Click on the bell, and we're looking forward to seeing you in one of our next videos. Thank you and bye-bye.